Hello, good morning. I am SEEMA GARG, Associate Professor in Chemistry, SPC Government College, Ajmer. Today, video 132. It is for BSc Part 1, Organic Chemistry, Paper 2, Unit 2. Alkynes. Alkynes, this is the syllabus of alkynes. Nomenclature, structure, method of formation, acidity of alkynes, mechanism of electrophilic nucleophilic addition reaction, oxidation, metal reduction, and polymerization. Structure of alkynes. Structure here. Here carbon is sp hybridized carbon. Here 1 sigma and 2 pi bonds are there. Bond length is 1.20 angstrom. Bond angle in between this carbon hydrogen, it is a linear molecule. Bond angle is 180 degree. Carbon hydrogen bond length is shorter than alkane and alkene. It is 1.06 angstrom. So this is the structure, molecular structure of alkynes. Here it is in alkynes, pi electrons are delocalized between carbon and carbon. See here, 2 p orbitals, side to side overlappings. Bond length, as I told you, it is shorter than alkane and alkenes. Bond energy. Here in bond energy of alkynes, it is higher than alkane and alkenes because of 2 pi bond and 1 sigma bond. So total energy is, bond energy is about 207 kilocalorie per mole. Nomenclature. Alkane, N is replaced by ine, alkyne. Here also we have to select the longest chain of carbon and the triple bond alkyne. We have to give numbering from the triple bond present, nearest triple bond present to the longest chain. See here, this is 3 hexyne. It is 2 pentyne. Here, 4,4-dimethyl 2 pentyne. Substituents, we have to give the second priority. First priority we will give to the triple bond present to the longest chain nearest. So it is 4,4-dimethyl 2 pentyne. It is 2,1-butyne here. If suppose double bond and triple bond both are present, then we have to give priority to double bond compared to triple bond. So see this molecule, it is 1-heptene 6-ine. Alkenyls groups. The monovalent groups derived from alkynes are given below, and these are named by replacing terminal carbon of parent alkynes by, terminal E of parent alkynes by L. See here, this is the ethinyl, propynyl. Methods of formations. Laboratory or commercial methods. Calcium carbide. When it is hydrolyzed with 2 water molecules, it will give acetylene or ethyne, and byproduct is calcium hydroxide. Calcium carbonate is decomposed to calcium oxide and carbon dioxide, and this calcium oxide will react with 3 moles of carbon. It will give calcium carbide and carbon monoxide. And this calcium carbide will hydrolyze and it will give us acetylene commercially. Second method, by dehydrohalogenation of dihaloalkanes. Alkynes are prepared by dehydrohalogenation of vicinal dihaloalkanes by heating them with an alcoholic solution of KOH. See, vicinal dihalides, when it is treated with alcoholic KOH, it will give us vinyl halide, and then on further it will give alkynes. Gem dihalide also give us alkynes. It is again treated with alcoholic KOH, and it will give in 2 steps. In first step and then second step, it will give alkynes. Instead of alcoholic KOH, we can use sodamide also. Suppose this sodamide is using and dibromo alkane, then it will give first vinyl bromide, and on further treated with sodamide, it will give this alkyne. By dehalogenation of tetrahalides, we can dehalogenate tetrahalides also. And first we are reacting with zinc and methanol solvent. It will give us this dihaloalkene, and on further reacted with zinc and methanol, it will give alkynes. Decarboxylation of acetylenic acids. Acetylenic acids, when decarboxylated in presence of sodium hydroxide, it will give alkynes. Sodium, this is a sodium salt, and then on further treated with, it will give alkynes. Here it is a propyne. By dehalogenation of haloform. Chloroform or iodoform, when reacted with 6 moles of silver, 2 moles of chloroform and 6 moles of silver, it will give ethyne or this molecule alkynes. Similarly, iodoform, 2 moles of iodoform, when treated with silver, it will give ethyne. We can also produce this ethyne with the help of all-base electrolysis reaction. Potassium malate, when ionized in the anion and cation. So this at anode, this anion will gain lose their electrons, and then it form acetylene or ethyne. At cathode, it will gain electron and it will decompose with water and will liberate the hydrogen gas, and potassium hydroxide is obtained. Alkylation of terminal alkynes. This alkyne will reacted with sodamide and liquid ammonia. It will give this sodium salt, and then it will reacted with alkyl halide in presence of liquid ammonia. and it will give this higher alkynes with Grignard reagent. These alkynes, lower alkynes, we can convert into higher alkynes with the help of Grignard reagent. This Grignard reagent is when reacted, it will form salt and then it will decompose. It will give us higher alkyne. Synthesis from elemental carbon and hydrogen. It is called Berthelot's synthesis. We can synthesize acetylene with the 2 moles of carbon and hydrogen in presence of electric arc. It will give acetylene or ethanol. Physical properties. Physical state. C2 to C4 means ethine, propyne, and butane. Carbon family of this alkynes are colorless gases. The next 8 are liquids, while the higher ones are solids. Smell. All the alkynes are odorless. However, acetylene has garlic smell. Melting point, boiling point. The melting point, boiling point of alkynes are slightly higher than those of the corresponding alkenes and alkanes. This is probably due to the reason that because of the presence of a triple bond, alkynes have linear structure. Hence, their molecules can be more closely packed in the crystal lattice as compared to those of the corresponding alkenes and alkynes. Solubility. Alkynes like alkanes and alkenes being non-polar are insoluble in water but readily dissolve in organic solvents such as petroleum, ether, benzene, and carbon tetrachloride. Density. Densities of alkynes increases as the molecular size increases. However, they are all lighter than water since their densities lies in the range 0.69 to 0.77 grams per centimeter cube. Acidic nature of alkynes. The hydrogen atoms attached to a triple bond of alkynes, acetylenic hydrogens, are acidic in nature. See here, acidic nature is decreasing. Here, alkene to alkene, because here S character is also decreasing. So this is all about the structure, method of formation, physical properties, and acidic nature of alkyne. Thank you very much for today's lecture. In next lecture, we will see the chemical properties of alkynes.